Hi everyone, good morning. Can you hear me? Hi everyone, can you hear me? If you can hear me, please say yes or say something. Tuti, Soumya, Aishwarya, anyone, if you can hear me, please say yes. Okay, great. Please keep all your devices on mute, okay, so that there's no disturbance during the class. Also, nobody will be scribbling on the screen, okay, because that creates a lot of disturbance. And we'll wait for 2 more minutes, okay. Today's uh, today's concept that we are going to learn in quantitative aptitude is numbers, okay. So we'll see what all type of numbers are there and what all questions can be asked from numbers. This class is important for both the students, okay, from CUET and IPMAT, because in CUET this will be coming under quantitative ability, okay, which is under general test section 3 of CUET. And IPMAT, very obviously you know that in all the IPMAT exams, Indore, JIPMAT, Rohtak, this is very common, okay. In fact, if you're writing some exams like NPAT, SET, Narsi Munji's BBA exam and Symbiosis BBA exam. In fact, some of the students will also be writing IPU CET, right? In the Vista University CET. In that also you'll be encountering questions related to numbers. Okay, so this is a very basic concept. This builds your basic, because if you go further from here, what will happen? There'll be questions like X is a whole number and X is this. That kind of conditions will be given in questions. Okay, so why are we studying numbers first? Because use of numbers is a lot, okay, in the upcoming concepts. So that's why we are studying numbers first. So just give me a thumbs up. Just write a yes in the chat box if all of you can hear me. So far, only Soumya has written. I want all of you to write a yes if you can hear me very clearly. Fine. Okay. Let's start. I'll be sharing my screen with you. Just confirm if you can see my screen. Okay. Is my screen visible to everyone? Numbers basics is written on
Yes,
the
sir.
screen. Okay, great. So today we will be dealing with the basics. Okay. I'll not be going into uh, a lot of depth, because from today's point of view, that is more than enough. Okay. इतना भी अगर आप कर लेते हो, then you will be doing good. And next week we'll be dealing with some advanced concepts. Okay. So today we'll only be discussing what are the type of numbers, why are they important, LCM, HCF, and little bit of questions also we'll be dealing with. Okay. Because what happens in the upcoming concepts, when you'll be facing questions, if you misread a question or you misunderstand a question, right, due to very small concept related to numbers, you might solve that question incorrectly. Okay. So that is why we are studying numbers. So today's concept is numbers basics. Okay. So first of all, here we see what are the type of numbers that we have. Okay. See, quantitative ability is a subject which is not new for anyone. Okay. Because we all have studied this subject till class 10. And in fact, in CUET, only mathematics till class 10 will be coming. Okay. And in IPMAT, there is little bit extra mathematics from class 12, but that is only a part of IPMAT Indore. Okay. So first of all, when we study the type of numbers, when we study numbers, we should not be afraid of this concept. Okay. We should not be afraid of, in fact, the whole quantitative ability, because this is something we have already studied. Okay. Let's come to the type of numbers. I think you all are very much familiar. Even numbers, the numbers which are divisible by 2 are called even numbers. Odd numbers, numbers not divisible by 2 are called odd numbers. Is this clear to everyone?
Oh, yes, sir.
Fine. When we come to prime numbers are those numbers which have only two factors. That means which are either divisible by themselves or by 1, right? That is definition of a prime number. So if I take example of an even number, it is say 2 or 20. Odd number is 3, right? Not divisible by 2. But when I come to prime numbers, say I take a number 17. Okay, 17 is only divisible by 1 and 17, right? So that's why it's a prime number. Okay. So in a lot of cases, you'll be seeing that we have been given x is a prime number, and there will be a question based upon it. Next, we come to composite numbers. Okay. We'll be checking them in detail. I'll be giving you some examples as well. So have you heard of composite numbers?
Yes, sir.
Yeah, even if you don't have, we'll be dealing with this. Decimals are very common, right? The numbers that we can see having a decimal part, for example, 2.4. This is a decimal number because there's a point in between. So every number where you see a point, it's a decimal number. What are fractions? Fractions are those numbers which are written in this form, a by b, right? In form of a by b. So there is a numerator. This above part is called numerator, right? And this number at the bottom below this dash is called the denominator. Okay. So that's all about decimal and fractions, rational and irrational numbers. See, this is something that we encounter in class 9 basically. Okay. So composite numbers, please tell again. So Mehak, composite numbers will be dealing in detail. Okay. Composite numbers are those numbers which can be written in the as a product of their factors. Okay. Prime factors. We'll see this in detail ahead. Okay. I'm just telling you the type of numbers here. So then we have rational and irrational numbers. This also we'll see. So students usually encounter rational and irrational numbers in class 9. Okay, that's when we pay attention because our whole mathematics initial few chapters are based upon rational and irrational numbers. Okay, so we'll see this. We have the definition in detail. I'm just telling you the type of numbers first. Okay. Then we have natural numbers. This is also a very familiar term. All the numbers one onwards, one, two, three, four, five, six, all these numbers, right? From one onwards are called natural numbers. And natural numbers don't have a decimal part. We'll see this in detail. What are integers? This also we have heard, right? So integers are those numbers which don't have any decimal fraction. But what is the difference between natural numbers and integers? Natural numbers are one or number greater than that. Okay. The number one, or you go to any complete whole number, 2, 3, 4, 5, 6, up till plus infinity, which do not have a decimal part are called natural numbers. So natural numbers are positive. Integers, what are integers? All the numbers not having a decimal part, they and in fact in integers we include the negative one as well. Okay. For example, I say -2. -2 is not a natural number, okay, because it is negative, but it's an integer. Okay. We'll see a lot of examples ahead. Okay. And I'll be asking you questions as well. Real numbers. What are real numbers? Real number is a big term. Okay. Real numbers are all the numbers in the world can be called real numbers. Okay. Except imaginary numbers. So there is something called imaginary numbers as well, but that is not relevant for CUT. Okay. Students who are here for CUT, usme imaginary number will not be asked. Okay. Last we have whole numbers. Good morning, Karan. Last, we have whole numbers. So what are whole numbers? This also we'll see, okay? I just made you familiar with the type of numbers that we have. Now let us see them in detail, okay? So see, one by one, I'm going to explain everything. Pay attention, okay? First, we have integers, okay? Integers are numbers that consist of whole numbers and negative numbers, okay? Integers do not have a decimal or a fractional part. A number line is full of integers. What is a number line? We'll see that. On the left side, you can find negative integers, while on the right side, you have the positive ones. So integers, for example, I say -4. This is an integer. Why? Because it does not have any decimal part. It is not a fraction, right? And then this is, even though it is negative, but it's a complete number. It does not have any fractional or any decimal part. So this is an integer. 0. 0 is also an integer. 1 is also an integer. Say I say 523. Is this an integer? Yes, this is an integer. If I go to negative side, say -17, is this an integer? Yes, this is an integer. Is this clear? Definition of integers is clear.
Yes, sir.
Okay, others also can like type or speak, okay, if they have any doubt. So that's all about integers. Okay. Integers are whole numbers. They can be negative or positive. Okay, they do not have a decimal or fractional part. That's it. Now let us move to even and odd numbers. You already know this. Even numbers are those numbers that can be divided into two equal groups or pairs and are exactly divisible by 2. For example, 2, 4, 6, 8, 10, and so on, all of these are even numbers very clearly. So when we divide a number by 2 and there is no remainder remaining, then they are called even numbers. Okay. In other words, these are whole numbers that are exactly divisible by 2. So if I say 2.2, now you'll say that, sir, this is also divisible by 2. Is this an even number? No. Even numbers are
Yeah.
whole numbers, okay, that are exactly divisible by 2. Is this clear? Even and odd numbers?
Yes, sir.
Similarly, if I say 3.3, this is having a decimal part, fractional part. But is this an odd number? No, because odd numbers are whole numbers, okay? They can, even though it is divisible by 3, but this should be a whole number. It should not have any decimal or fractional part, okay? I think the definition and examples of even odd numbers and integers are clear to you. Do
Yes.
you have any doubt? If you have any doubt, you can put it in the chat box or even speak, okay? No doubt, right?
No, sir.
Fine. So far we have seen what kind of numbers do we have, and we have studied two kind of numbers very thoroughly. Let's go ahead, okay? Now we have this. So natural numbers and whole numbers. Okay. So when we come to natural numbers and whole numbers, a natural number is a non-negative integer and is always greater than 0. It is represented by the symbol n. So this you do not need to pay attention to symbol n. This is quite relevant for IPMAT people. We'll tell this how. ये हम discuss करेंगे in set theory, okay, when we come to higher maths. But for CUT students, you just have to pay attention to this part. A natural number is a non-negative integer. So I told you what is an integer, right? Integer is a whole number, okay? It does not have any decimal or fractional part. So non-negative means positive, okay? So from 1 onwards, if I talk about natural numbers, okay, let me call n. Natural numbers are 1, 2, 3, 4, so on, so on, so on. Go till plus infinity, okay? These are natural numbers. What are whole numbers? As soon as, see, we already know that 1 onwards, 1, 2, 3, 4, all of these are natural numbers. As soon as I add a 0 to it, the list of these numbers, we get the list of whole numbers. So whole numbers don't have a decimal part. Okay. यहाँ पे लिखा हुआ है. It is written here. It should be noted that whole numbers do not contain any decimal or fractional part. So whole numbers are from 0 onwards. Okay. 0, 1, 2, 3, and so on. They do not have a decimal or fractional part. Beyond this, we do not have any whole numbers. Okay, this is about whole numbers. Got it? So when if they ask you, what is 0? Is 0 a whole number? You will say yes, 0 is a whole number because it does not have any decimal part. Okay, and it is non-negative. Got it? Got natural
Yes,
numbers
sir.
and whole numbers. Okay?
Sir,
Yes.
sir, but non-negative integer in case of natural number, but natural number in that zero won't come. Then non-negative integer.
See, in natural numbers, we don't have a zero. Okay, you have to remember this. Zero is not a part of natural numbers. Okay, natural
Yes,
numbers
sir,
are
but
one
in
onwards.
integer zero will also come. A natural number is a non-negative integer,
Yeah.
but then zero will also come in that definition.
It comes, but see, this is a combined definition of natural and whole numbers, okay? So you have to clearly remember that natural numbers are one onwards, okay? So you can say natural number are positive whole numbers, okay? You can say that positive whole numbers. Zero does not have any sign, right? It is non-positive, non-negative, right? So positive whole numbers are natural numbers that you can say, okay? Is that clear?
Yes,
This
sir.
basically is a combined definition of natural and whole numbers here, okay? So that this is clear, right? One onwards, all the whole numbers are called natural numbers. If you include zero as well, then it becomes a list of whole numbers. Got it?
Yes,
Yes,
sir.
sir.
Okay, let's move forward. Now, somebody was asking me about this, right? Prime number, composite numbers. So let's study prime numbers and composite numbers. Okay. A prime number is a number that has exactly two factors that I already told you. For example, 2. 2 has only two factors. What are factors? Factors are those numbers which divide the given number, okay, completely without leaving any remainder. So, prime number is a number that has exactly two factors, 1 and the number itself. Okay. For example, 2, 5, 7, 11, and so on are prime numbers. And it can be said that any whole number greater than 1, which has exactly two factors, 1 and itself, it is defined to be a prime number. Okay. So for example, you say 13. 13 is divisible by 1 and itself, which is 13 only. It has only two factors. Okay. The number 1, it should be divisible by only 1 and the number itself. What if I say minus 17? This is not a prime number, okay? Because when we say prime number, whole number, natural number, these are only for 0 and numbers ahead, okay? We don't go to negative part. Got it? Is this clear?
Yes, sir. Yes,
Okay.
sir.
Now, let us study composite numbers and then we'll come to this statement that I've written in white, okay? So a composite number is a number that has more than two factors, right? If it has only two factors, one in itself, then it would be called a prime number. But a composite number is a number that has more than two factors, which means it can be divided by the number 1 and itself and at least one more integer, okay? At least one more integer. It can also be said that any number greater than 1 that is not a prime number is defined to be a composite number. Composite numbers always have more than two factors. So whenever somebody asks you what is the difference between prime and composite number, you will say composite numbers always have more than two factors, while prime numbers only have two factors. For example, 6. So if you write 6, how will you write the prime factoration of 6? What are the factors of 6? 1 divides 6, 2 divides 6, 3 divides 6, and 6 itself divides 6, right? So 6 is a composite number because it has more than two factors. Is this clear?
Yes, sir.
Fine. Now here we have written one statement, which is 1 is neither prime nor composite. So 1 is not prime because 1 has only one factor. Prime numbers have two factors. Okay. And it is not composite as well because composite numbers have always more than two factors. So this can be asked, if not in IPMAT Indore straight away, maybe in JIPMAT or Rohtak, or maybe in any other exam. Is 1 prime or not? 1 is not prime. Okay, 1 is neither prime nor composite. Is it clear? See, right now we are only going through the definitions. Once we start applying them, we encounter all these statements in the questions. It'll be very clear. Okay, is this clear, everyone?
Yes, sir.
Great. So let's go ahead. Now see, this is something you should remember. Okay. Sometimes there'll be questions in which you'll encounter. Uh, uh, Sometimes this is asked as a straight question. Okay. Straight away, these are questions. In fact, in CUT 2022 exam, there was a straight questions. There was a straight question related to this part. Okay. How many prime numbers do we have between 1 and 100? Okay. So if you want to remember, it will be very good. Okay, see, whenever we are solving mathematics and we are solving quantitative ability, there is a lot that you have to understand, but there's a lot you have to remember as well. Okay, you have to store that data within yourself. Like formulas, you'll have to remember. Few things help you a lot, and you really don't waste your time in the exam if you remember a few things. Okay, so we are just talking about the range here and how many prime numbers fall between in that particular range. So between 1 to 30, if you count, we have 10 primes. You can find out 2, 3, 5, 7, 11, 13, 17, 19, like that. Okay. So between 1 to 30, we have 10 primes. It's okay not to memorize this right now, but for later, if you encounter a question, you can always recall this. Okay. And when we talk about this range, 1 to 50, we have 15 primes. Okay. If we talk about this range, 1 to 100, we have 25 primes. If we talk about this range, 1 to 200, we have 46 primes. Most probably in IPMAT, they'll not be going beyond 100, okay? So even if you just remember how many primes are there between 1 to 100, there are 25 primes, okay? Or this, I'll tell you an incident. Sometimes they ask you in the interviews as well, okay? So in one of the IPMAT interviews, it was asked, okay, a student was asked, what is your favorite subject? He told, I like quantitative ability and mathematics very, I mean, a lot. So he was straight away asked by the interviewer, okay, if you like mathematics or quant so much, just tell me how many primes are there between 1 to 100, and he could not answer, okay. Okay. So
Yes, sir.
it can be useful for those purposes as well. Okay, maybe because it's a very basic question, they might ask you in interviews of maybe symbiosis. They also have interviews, right? Then IPMAT, you have interviews, right? So it can be very helpful there. Okay. I hope this is clear, right? This is something we should memorize. Okay. Otherwise, you guys
Yes,
already
sir.
know how to find out prime numbers. Okay, fine. Let's go ahead. Now, this is something which I'm going to tell you, and this is more relevant for IPMAT students. Okay. CUT students, see, CUT students have a very big dilemma whether we should study some concept or not. Why? Because see, CUT is in a very immature stage. Okay, this is the second time CUT is being conducted in 2023. Next year it will be conducted in 2024. Okay, and in fact, most probably IPMAT students will also be writing CUT, right? So CUT students have this very big confusion, sir, we should study this or not. So CUT, since it is in very initial stage, they are giving very easy questions right now. Okay, but since 16 lakh people are writing CUT, please turn off your mic.
हाँ चल रही थी उतना लेट आएगी तो बंदे हो जाएगी ना।
Just a second. So CUT students should also be more towards learning as much as they can, okay? Because CUT might be becoming tougher in the upcoming years, okay? So this might be helpful for CUT as well. So you guys can study, but IPMAT is definitely relevant, okay? So what are co-prime numbers? Many of you might be hearing this term for the first time. You must have heard prime, okay? Composite, all of those terms you've heard. But what are co-prime numbers? See, co means whenever we talk about co, we are talking about a pair, right? If a pair of numbers has no common factor apart from one, then they are called co-prime numbers. Okay. In other words, a set of numbers or integers which have only one as their common factor, which means their highest common factor HCF will be one, then they are co-primes. These are also known as mutually prime numbers or relatively prime numbers. Also, there should be two numbers in order to form co-primes. Is this clear? If two numbers have only one factor, common factor, or their HCF, if it is one, then they are called co-prime. And to determine whether two numbers are co-prime or not, we should have at least two numbers. Okay. Is this clear?
Yes, sir.
Okay, great. So that's it. For example, I ask you 3 and 5. Are they co-prime? You will straight away find their HCF, which is 1, right? So you'll say, yes, sir, these are co-prime. If I ask you 2 and 4, are they co-prime? You'll say no, because their HCF is 2. Okay. Yes, yes. So, Abhigyan and Mehak, आप इसी का example पूछ रहे हो, right? Are you asking me the example of co-prime numbers only? Okay. Understood, right? If a pair, so 3 and 5 is a pair only. Are these co-prime? Yes, because their HCF is 1. 2 and 4, I asked you, are they co-prime? You said no. Why? Because their HCF is not 1, it is 2, right? So that is why they are co-prime numbers. So maybe straight away, if they ask in CUT, they'll just give you 3, 4. Are they co-prime? Okay. Uh, Now let's go ahead. Now we have fractions and decimals. Okay. So sometimes people are confused between these. What are fractions? What are decimals? What are whole numbers? What are integers? They have a very big mix up in their brain. That's why we are going slowly and with examples. Okay, let us study fractions and decimals. So fractions are a part of a whole. They are a part of a whole. So for example, what does this statement mean? For example, I have a cake, circular cake, and I cut this much cake. This is how we cut the cake, right? I take out this much portion from the cake. So this cake was a whole, and this piece is a part of the whole, right? So I took out some fraction of the cake. Okay. So fractions are a part of the whole. They are represented by numbers that have two parts to them and they are separated by a fraction bar. There is a number at the top which is called the numerator and the number at the bottom is called the denominator. For example, they have written 1 by 2. So a fraction will always have a numerator, will always have a denominator. So 1 by 2 is a fraction. But what if I say 2? Is 2 a fraction? You'll straight away say no because sir, it does not have any denominator. Okay. When you write a number in its simplest form, for example, I ask you 8 by 6. Is it a fraction? You'll simplify it. You'll cancel 2, right? 2, it can be cancelled by 2. So it will become 4 by 3. Now it cannot be cancelled. Nothing can be cancelled any further. So it becomes 4 by 3. You'll say, yes, it's a fraction, right? But if I ask you straight away 6, is 6 a fraction? You'll say no. Okay. And in fact, say if I ask you 12 by, say 4, whenever you have been given a number, you will always bring it to its simplest form. So 12 by 4 becomes nothing but 3. So is this a fraction? No, because ultimately when it simplifies, it does not remain with a denominator. Got it? This is all about fractions. Okay. When we talk about decimals, a decimal number has a whole number part and a fractional part. Okay. So for example, they have written 3.6 and these parts are separated by a decimal point. So 3.6, as soon as you see a point, you will say it's a decimal number. Okay. Got it? So for example, I say
Yes.
2.4. 2.4. This is also a decimal number. Okay. That's it. This was very easy. Okay. I
Sir,
hope this is
I
clear,
couldn't
right?
hear it. Is 8 by 6 a fractional fraction?
Yes, 8 by 6 when it simplifies becomes 4 by 3. It's a fraction only. It has a numerator, it has a denominator, 4 by 3.
But 12 by 4 is not fraction.
No, because 12 by 4, when you simplify it, it becomes 3 only, right?
Yes, sir.
What did I say? You have to simplify that particular. For example, 1 by 2 was given and it was in its most simplified form. You cannot solve it any further. You can, after this, if you want to write something about 1 by 2, you can straight away write 0.5, okay? In this case, 0.5, it becomes a decimal number, okay? But this is a fraction also. This is a fraction also 1 by 2. But 12 by 4, when we simplify it, it simplifies to 3. It does not have any part, okay? It's a whole number 3. That's why it is not a fraction, okay? Got it?
Yes, sir.
Yeah. Now let's talk about this. This is a very important concept, rational numbers and irrational numbers. So most of the students, you must have understood everything so far, okay? You might face some issues in rational and irrational numbers. Not in rational, to be very honest. Maybe irrational numbers you'll find very strange, okay, these numbers. So let us study what are rational and irrational numbers. A rational number is represented in the form P by Q, where Q is not equal to 0. Integers, fractions, decimals, whole numbers, and natural numbers are all rational numbers. For example, 1 by 2 minus 1 by 5, all are rational numbers. So a number that can be expressed in the form of P by Q, where Q is not equal to 0. These are called rational numbers. Why Q should not be equal to 0? Because if you write P by 0, it becomes undefined or infinity, right? This is the symbol for infinity. As soon as Q becomes 0, the denominator becomes 0, it has no meaning, okay? Okay? It becomes in an undefined form. So P by 0 is not 0. Okay, many students might be thinking P by 0 is 0. No. As soon as you get denominator as 0, it is undefined form. Okay. So it is saying integers.
Yes.
For example, 4. This is a rational number. Why? Because it can be written in the form of P by Q. 4 by 1. Where Q is not equal to 0. So 1 is not equal to 0, the denominator. That means it's a rational number. Fractions. Can fractions be written in the form of P by Q? Let's see 2.2. Yes, it can be written in form of P by Q, 22 by 10, right? So 22 by 10, if you simplify further, becomes 11 by 5. So 11 by 5 can be written in the form of P by Q, where P is 11, Q is 5, and Q is not equal to 0. So yes, fractions are also rational numbers. Decimals, again 2.2. Uh, decimals, I took decimal only, right? Fraction, if you take 3 by 4, 3 by 4 is a fraction, and yes, Q is not equal to 0. So it is also a rational number. Whole number. For example, 0. Let's take the most special whole number, which is 0. Is 0 a rational number? Yes, because it can be written in the form of 0 by 1, where Q is not equal to 0, right? We don't have any restrictions on the value of P, but there are some restrictions on the value of Q. Q should not be equal to 0. So when I write 0, a whole number, it can be written in the form of P by Q as 0 by 1. And very clearly, 1 is Q here, and Q is not equal to 0. So 0 is also a rational number, okay? Is this clear? Rational numbers is clear to you, right?
Yes, sir.
Yes. Now let us talk about irrational numbers. Irrational numbers will not be asked, in CUET, okay? They might ask you, but a very basic kind of question will be there from irrational numbers. While in IPMAT, you can see this maybe more frequently than CUET, okay? So irrational numbers are the numbers that cannot be represented using integers in the P by Q form. The set of irrational numbers is denoted by Q. So this is not relevant for CUET, denoted by Q. This is a part of higher mathematics in IPMAT. For example, root 5, root 2, and so on are irrational numbers. Okay, I'll tell you how they are irrational numbers. Irrational numbers cannot be represented as a simple fraction. Their decimal expansion neither terminates nor becomes periodic. What does this mean? See, if anyone of you knows the value of root 5, can you tell me root 5, root 2? Do you know? Anyone, if you know the value of root 5, root 2? If you have your mobile in front of you, what you should do is you should, just a second, I'll show you. Just a second, okay? I'll show you something. Can you all see my screen? Can you all see my screen? Hello? Can you all see my screen? Please reply if you can. Please reply if you can see my screen. Okay, is my voice clear now and can you see my screen properly?
Yes, sir.
Okay. So we just discussed that root 5 is a, you can say irrational number, right? We just discussed this in one of the example, and that's why I am finding out the value of root 5 over here. So it is clearly, pay attention to the value of root 5 very clearly. Okay, so this is 2.236067,977, and it'll keep going on, right? Similarly, if I find out the value of, say, if I find out the value of, say, root 3, okay, what will be the value of root 3? It is this, okay, 1.236067. 732, 050, 80757. So when we check the value of root 5 and root 3, we do not see any repetition, right? In the values that are coming after the decimal, right? The numbers are not repeating. Sometimes it is 732, then 050, 807. There is no particular repetition or pattern, right? Is that clear? When we check the value of root 3, root
Yes,
5,
sir.
which are irrational numbers, we do not see any pattern or repetition, okay, of numbers, right? So what do I want to say here? What do I want to say here is, see, now when we come to our definition of irrational numbers, we were told that the set of irrational numbers is denoted by q. For example, root 5, root 2, and so on are irrational numbers. Irrational numbers cannot be represented as a simple fraction. The decimal expansion neither terminates nor becomes periodic. So when we check the value of root 5, it was 2.236050. It keeps going on. It keeps going on. Okay. It never stops. And also there is nothing periodic. By periodic, it means pattern only. Okay. There is no pattern and there is no termination. The number keeps going on. Root 5 if you calculate. Okay. And root 2, same. I calculated root 3 in front of you, right? Root 3 was 1.732 and something, something, something. So the value of irrational number never terminates. Okay, वो कभी terminate नहीं होती है. Is this clear to you? And they cannot be
Yes, sir.
expressed in the form of P by Q. We'll see this in detail, but for now, this is what we need to go ahead with. Okay, irrational numbers. When we face questions where more information about irrational is required, we'll see it. Okay, is this clear?
Yes, sir.
Great. Now let us come to real numbers. Okay. So real numbers. What are real numbers? I told you any number that can be found in the real world is a real number. Any number that we can think of except complex numbers is a real number. So if I say 0, you'll say yes, it's a real number. If I say 1, you'll say yes, it's a real number. If I say minus 1 by 2, you'll say yes, it's a real number. Okay. Uh, if I say a number root 3, which was irrational, right? If I ask you, is it a real number? You'll say, yes, it's a real number. If I write a -4, you'll say, yes, it's a real number. Okay. If I write, say 3 by 2, you'll say, yes, it's a real number. Okay. If I write 0, you'll say, yes, it's a real number. So every number that we can think of and use in the real world is a real number. We use 0, right? We use 1, we use -1 by 2 in calculations. We use root 3 as well. -4, 3 by 2, 0. All of these numbers are highly useful. So all numbers that we can think of in the real world are real numbers, except for complex numbers. Now this complex number is not important for CUT again, okay? So we'll discuss this in a separate class for IPMAT when we go to the advanced portion, okay? Clear? All clear about real numbers?
Yes, sir.
Fine. So if anyone is facing any doubt so far in the definition of odd, even, composite, prime, co-prime, real number, whole number, you can let me know, okay? Fine. Let's go ahead. This is very important, okay? This is about number line. What is a number line? So this is something that most of us know, okay? Because we encountered this in, I think, class 8. Class 8, 7, we encounter the concept called number line, okay? So everyone must have seen this. A number line is a visual representation of numbers on a straight line. As we move towards the right side of the horizontal number line, the numbers increase, okay? And if we move towards the left, the numbers decrease. So if I am say, how do we represent a number line? A number line is like this. So what is complex number? Complex number. Yes, yes, I'll tell you complex number. Doubt in co-prime number. Fine, math. Very good. Very good to see that you guys are participating. Okay. Let's learn number line. Number line is a very easy concept. Here we'll discuss co-prime and complex numbers. Okay. So a number line is represented like this. Okay. If I tell you, okay, Abhigyan, draw a number line, you'll just make a horizontal line, put a 0 in between, and you'll put these dashes, okay, that you can see all these dash, 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 okay, to represent the numbers. On left side of 0, when we go to the left side of 0, we'll see negative numbers. All the numbers to the left side of 0 on the number line will always be negative. Got it? But if we go to the positive side of 0, okay, positive side of 0 or right side of 0, numbers will be positive numbers. Now, this will be 1, this will be 2, this will be 3, this will be 4, right? This will be 5 over here, 6, 7. What did the definition say? You can represent any number on the number line, right? So if I represent, say, 1.2, 1.2, so it will be slightly ahead of this one, right? We have our 1 over here, 1.2 will be somewhere around here. So that also can be represented over here, okay? So all the numbers can be represented on a number line except complex numbers, because complex numbers have another name called imaginary numbers. So we are studying in class 11, 12, and we have never heard of a number called imaginary numbers in our calculations, right? So complex numbers are also called imaginary numbers. Why they are called imaginary numbers, I'll tell you. So you had a doubt in. Uh, is this clear? The number line is clear, right? We'll use number line in a lot of
Yes, sir.
cases, right? Yeah. So let us let me clear your doubt of composite numbers and imaginary numbers. So I'll tell you about imaginary numbers first. See, in mathematics, whenever we find out, value of some number, it could be like we might be given a fractional value and we convert it into decimal, right? So 0.66. If I write 2 by 3, the value of 2 by 3 will be 0.666 something, okay? If I'm given 1 by 3, my value will be 0.333 something like that, okay? Yeah. So I might be given fractions in negative form, say minus 1 by 5, then the answer would be minus 0.2. Just a second. So 1 by 5 minus 1 by 5 is minus 0.2, right? If I tell you to calculate, say, square root of 36, you'll give me a 6, right? Or to be more precise, this is plus minus. If I tell you to find out the value of root x, you will say plus minus x, right? So this is how we usually calculate, okay, when we have to do some kind of calculation. Either we add or multiply, or if we have numbers to simplify, the most simplified form in which I can write it would be like this. I can calculate value of a fraction, value of a decimal, value of a square root, right? If I write square root of a negative number, say minus 6, root of minus 6, or root of minus 3, do you know how to calculate this? Yes, Shrishti, all rational numbers are real numbers, okay? All rational numbers are real numbers. Because what can be a rational number? 0, 1 by 3, है ना? Negative as well. So all of those are real numbers. So you must have heard of numbers like root 36, root 4, root 9, but never of root of a negative number. So when you face a situation when you have to calculate root of a negative number, then how is it written? First of all, what we do is, because we have a root sign over this 3, right? So very obviously, I'll take out a root 3 because root 3 is written as root 3. But what about this negative sign over here? So I'm going to tell you a thing. Root, this negative is nothing but root of minus 1, right? Because if you write root of minus 3, you will write it as this, right? Root of 3 into minus 1. We can write it like this. When I talk about this root 3 inside the root, it comes out as root 3. But what about this root of negative 1? It is always written as I, which is called nothing but iota, okay? I think class 11 students must be knowing this. This is called iota, okay?
Yes, sir.
Which
Yes.
represents imaginary numbers, okay? So this root negative, if you find out root of a negative number, it is always an imaginary number or a complex number. Now, this is imaginary, okay? So far, I'm only talking about imaginary number. What if I attach something else to this iota number? So how will you write root of -3, root 3 iota? Okay. Or we can also say iota square. If you square iota, you will always get -1. Okay. This is something that you can memorize. Okay. So root of negative is always iota. For example, I tell you to find out the root of, say, root of -12. How will you find it out? You know that first of all, you will write root 12 and then iota. This iota will not be under the root, okay? Right. If I tell you to square this root 12
Yes,
iota,
sir.
if I tell you to square this root 12 iota, what will you get? If you square root 12, you will get 12. And if you square iota, I have told you iota square is -1. So -12 will be your answer. Okay. This is how we use iota. What are complex numbers? So a complex number is written in the form of a plus iota into b. Okay. Where this a is the real part, because a is will be a real part, and this b, because iota is attached to it, is called the imaginary part. Okay. This is called imaginary part of that number. This is real, this is imaginary. So a number, if it is written in the form of a plus iota b, where it has a real part with an imaginary part, then it is called a complex number. Okay. So this is complex because it is really complex. You can see here throughout throughout your class 11, 12, 8, 9, 10, wherever you've studied mathematics, I don't think you have seen anything like a plus iota b, right? We encountered this in 11, 12 maybe, yes, but not till 10, right? The only reason is it is really complex because it has a real part, imaginary part. We usually don't face this. Even if you go to your maybe engineering or whatever you'll be pursuing in future, you'll rarely see real numbers unless you take mathematics as a subject for your degree, okay, for your graduation. You will not be seeing.
Iota we asked in CUET.
No, 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 not in CUT, okay. They might, they see CUT has a rule. CUT, when it releases the syllabus, it says that in general test portion, they mention very clearly that mathematics till class 8 will be asked. Okay. So they are more interested towards a mathematics till class 8. But what did I say? Because there are a lot of people who are writing CUET. So due to the competition, they might increase the level of examination any year. Okay. Whenever whenever an exam is whenever an exam is introduced, okay, initially it is very easy. Okay, very easy papers will be released, but over time um, it becomes difficult. Okay, so same was the case with your IPMAT exam as well. Initially when it came in 2011, Indore conducted the exam, it was very easy. In fact, if you see this JIPMAT exam, JIPMAT is not very old. Okay, I mean it's few years old. So that is the reason JIPMAT is so easy. And one another reason for JIPMAT being so easy is because it is for baby IIMs. Those are called baby IIMs, Jammu and Bodh. Okay, so that's why the exam is so easy. But Indore, this would be the 13th year of IPM for IPMAT Indore. So that's the reason IPMAT Indore exam is slightly difficult. Okay, there you might be facing complex numbers, but they haven't asked it. Okay, if you check past 4 or 5 year papers, they have not asked uh, complex numbers. They sometimes they ask in the interviews because IPMAT in the Indore interview is academic heavy. Okay, little bit academic heavy. So if you pay attention to your class subjects, you can perform really good. Okay, really good in the interviews because they are not taking a lot of weightage from your class 10, 12 marks Indore. They're not taking any straight. They're not giving any extra marks for your class 10, 12 performance. Okay, but they ask in the interviews. So that is why you should study for Indore interviews. Okay, this can be very helpful. People have been asked about complex numbers in the interviews. Okay, I hope this is clear. The complex number thing is clear, right?
Yes, sir.
Yeah. So whenever we usually face complex numbers when you have a situation like this, root of negative number. So root of negative is written as iota. Iota square is -1. Okay, that's it. And what is a complex number? A complex number is written in the form of a plus iota b, where a and b are basically real numbers. I is represented as iota. Okay, that's it. Now somebody was asking me about composite numbers. See, composite numbers. Composite numbers. What are composite numbers? It was very clear that a composite number will always have more than two factors. It was clearly written. So if even if you memorize this line only, composite numbers always have more than two factors. Then what is the confusion here, right? For example, I ask you two. Two, if you check its factors, has only two factors, one and two. Does two have more than two factors? No. So it is not a composite number, okay? And composite numbers are not negative. They are not negative, okay? What was the doubt here? I think Mahak was asking me the doubt. अच्छा को प्राइम नंबर में डाउट है किसी को सर ऑल रियल नंबर ये तो मैंने बता दिया है डाउट इन को प्राइम ओके महक हैड अ डाउट इन को प्राइम जस्ट अ सेकंड महक या को प्राइम so it said that co-prime is a pair of numbers that have no common factor apart from one, or you can say the HCF of this pair of numbers. If it is 1, then they are co-primes. That's it. For example, say I take 4 and 7. 4 is not a prime, 7 is a prime, but they are co-primes. Even though 4 is not a prime, but 4, 7 are co-primes. Why? Because their HCF is 1, right? Their HCF is 1. If I say 15 and say 4, are they co-prime? See, the numbers individually, they are not prime, but mutually they are co-prime. Why? Because their HCF is 1, right? They have no other common factor apart from 1. Is it clear now, Mehak? The definition of co-prime? Don't look at these numbers, okay? Just focus on their HCF or the common factor. If it is 1 only, then they are co-prime. Yes. I think you are confused in this case. You might be thinking that we always have to take prime numbers like this 3, 7. Both should be prime, then only we can determine they are co-prime. No. Co-prime means look at both the numbers, look at their HCF. If it is 1, then they are co-primes. Very good. Let's go ahead, okay? Are you enjoying? Are you getting everything?
Yes,
I just want to
sir.
ask. Yeah,
Yes.
great. So we have learned a lot, okay? If you check from the very beginning, we know even odd numbers very clearly now. Even if somebody asks you on the street, then also you'll be able to answer. Okay? All of these should be on your tongue, okay? Always. Integers we know, even odd we know, natural numbers we know whole numbers as well, prime also, composite also. This range, I told you the importance. Why do we have to remember this? Co-prime numbers. I'll also be sharing the PPT as well, okay, in the group after the session is done. So keep this with yourself. Fractions and decimals we know, rational, irrational we know, real we know. In fact, we know complex as well now. Number line we have seen. Let's talk about factors and multiples, okay? So how many of you know what are factors, what are multiples? How many of you know what are factors and multiples? Anyone? You can even you can just say गीजर factor ये होता है, multiple ये होता है. Nobody? I know. Great. See, IPMAT is such an exam, CUT is such an exam where you already know a lot of stuff. Okay. So that is the very reason CUT is conducted right after 50 days of your board examinations. Because domains, so you already know. English general test is something that you know about. And English we have already studied. General test ke andar, what do we have? We have quantitative aptitude, which we have seen. GK current affairs we study. Since childhood, we even play quiz games and all. So you never have to be scared, okay? In fact, even if few concepts scare you, just get your doubts resolved. Solve some questions. It will be clear, okay? Factors are those numbers which divide any number and multiples obtained when number is multiplied by number. Great. So my factors means possible number which are divisible by like factor. Okay, fine, you know it. So I'll just we'll just recall this. Okay, factors are the numbers that divide the given number completely without leaving any remainder. Okay, whereas the multiples are the numbers that are multiplied by the other number to get specific numbers. Factors of a given numbers are numbers that can perfectly divide that given number. So for example, factors of 6 are 1, 2, 3, 6. Why? Because 1 can completely divide 6, 2 can completely divide 6, 3 can completely divide 6, 6 can completely divide 6. But if I talk about 9, is 9 a factor of 6? No, because 9 cannot divide 6 completely. Yes, Soumya, correct. Is this clear? So factor is a very easy thing, okay? What are those numbers which can divide a given number? For example, if I say 25, you will say 1 is the factor of 25 because 1 is dividing 25 completely. 5 is dividing 25 completely, so 5 is also a factor. And similarly, 25 is also a factor of 25. Got it? On the other hand, a multiple of a number is a number obtained by multiplying the given number by another whole number. So sometimes students are confused in factors and multiples, okay? You should have this clear differentiation between factors and multiples in your brain. Because what we do is when we read a question now, we keep recalling what is in our brain. And if we have even a slight confusion, we either leave that particular question or we are left confused. Okay, so there should be a clear distinction. Factors are numbers which completely divide a given number without leaving a remainder. Multiples, for example, I say, tell me the multiples of 3. So 3 has a multiple, 3 into 1, which is 3, then 6, then 9, okay, and so on. So multiples can be infinite, okay? There can be infinite multiples, but factors are limited. Because if I ask you factors of 12, you'll say, sir, 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 12 is a factor. So factors are always limited, while multiples is a big set, okay? You can multiply any number with a number and get another number. So it becomes a multiple, okay? So for example, I have written here, multiples of 3 are 3, 6, 9, 12, 15, next would be 18, 21, so on, so on, so on, so on. This keeps going on till infinity, okay? So multiples का कोई limitation नहीं है. They don't have a limitation, okay? Is this clear? I think this was very easy, not very tough.
Yes, sir.
Clear? Great, great. Let's go ahead. Let's talk about this now, HCF. This is another very familiar term, highest common factor. The highest common factor of the two numbers is the largest whole number, which is a factor of both. It is also called greatest common factor. Okay? HCF of 15 and 21. So now you know factors. How to calculate HCF? I'll show you an example. So 15, I'm just recalling it. Okay, don't feel that I'm telling very basic things. I'm just recalling the basics because even in IPMAT, if you have difficult questions, those are based upon the basics only. Okay. Yeah, correct. So 15. How to find out the HCF? First of all, you will write the factorization, prime factorization of HCF, or prime factorization of the given number. Sorry, okay. So 15 can be written as 3 into 5. You only write the prime factorization, okay. Don't write 1 here. Don't write 1 into 3 into 5. Otherwise, I can write 10 times 1. 1 into 1 into 1 into 1, 3 into 5. Only write the prime factorization. So 3 into 5, 21. 21, is it divisible by 2? No. Is it divisible by 3? Yes. So I'll write 3. And further 7. So highest common factor of two numbers is the largest whole number, which is a factor of both. So we can see 3 is coming in the prime factorization of 15 as well, 21 as well, and 3 is the greatest number which we can find common between those. So 3 is the HCF. Similarly, if I ask you to find out the HCF of say 21 and 63, how will you write it? See, smart students, they'll just check if 63 is a multiple of 21 or not. So 21 divides 63, so we'll straight away say HCF, but there'll be some students who will be writing like this. 21 as can be written as 3 into 7. While if you write 63, it can be written as 3 into 3 into 7. So what is common? 3 is common, a 3 is common, right? A 7 is common. But for this 3, I do not find anything common above, right? So I can find a multiplication of 3 and 7 common. So 3 into 7 will be the HCF. This is 21. So HCF of 21 and 63, it is 21 only. Okay. Highest common factor. Okay. Highest common factor. Stuti, it was highest common factor. Highest common prime factor नहीं बोला था. Highest common factor. So 21 and 63, if you do their prime factorization, we get 3 into 7. 63, we get 3 into 3 into 7. So we can see 3 is also common, 7 is also common. So we'll take both. Whatever is common, we'll take all of that out. Okay. So 3 into 7 was common. We got 21. Is it clear to all of you?
Yes, sir.
How to find out the
Yes.
highest common factor? This is not something that we should actually solve here because, but बहुत basic है. I hope this is clear. For example, I'm giving you a question. Find out the HCF of say 35 and say 21. Okay, this is very easy. Find out the HCF of this 35 and 21. Great. You guys are very smart. Okay, already. Fine. This was very easy. Okay, let's go ahead. Let's talk about LCM now. Okay, fine. All of you are correct. Okay. So when we talk about LCM, which is also called least common factor, least common multiple. Okay, this is multiple, not factor. So now we have a differentiation between factor and multiple, right? HCF was highest common factor, while LCM is the least common multiple. So someday somebody asks, what is the basic difference between HCF and LCM? You'll say, in HCF we find the factor. In LCM we find the multiple, okay, of given numbers. Okay, fine. So when we consider two numbers, each will have its own set of multiples. So if I say I have a number called 3, I'll have its multiples. Then if I take another number, it will also have its multiples, say 7. So 7 will have multiples, 7, 14, 21, so on. Some multiples will be common to both numbers. Of course, the smallest of these common multiples is called the least common multiple of the given numbers. So we have to find out the LCM of 8 and 10. How to find out the LCM? See, during childhood, we are told this technique, right? कि ऐसा कुछ बनाओ, draw something like this, and write the numbers for which you have to find out the LCM, right? 8 and 10. So then we are told that find out the smallest number which can divide both. So it will be 2. So 2 if divide 8, 2 if it divides 8, we'll get 4. And 2 if it divides 10, we will get 5, right? We are told something like this during childhood. Then we again check, can it be divided by any number, small number? So yes, 2 divides 4. So we'll write 2. And this, since this 2 cannot divide 5, this 5 remains 5. Okay. Then we are again told, check again. So 2 divides this 2, so it becomes 1, and 5, it will remain the same. Now 1 does not have any importance here. So we'll just check whatever number is remaining. So 5. And ultimately we get 1, 1. As soon as we reach this 1, 1 thing, we stop and we multiply all of these which are given here. So 2 into 2 into 2, 8. 8 into 5 is 40. 40 is the given answer. 40 is the answer to this question. And this is how you calculate LCM. Okay, I hope all of you know this, right? Is there anyone who does not know this? Is there anyone?
No, sir.
Fine. Okay. See, in IPMAT, they'll ask an extension of this concept HCF LCM, where they'll ask you the HCF and LCM of fractions. Okay, we'll see that. First, let us complete whatever we are left with. If we are left with some more time, we'll discuss that as well. Okay, LCM and HCF of fractions. Okay, so far this much is clear, right? Yeah.
Yes, sir.
Let's go ahead. There is one very important relation related to this, okay, HCF and LCM. So remember this, okay, this can be useful for both of you, more useful for IPMAT students. That product of HCF and LCM of two numbers is equal to product of two numbers. Okay, and this is only applicable for two numbers. Okay, only applicable for two numbers. Okay, never forget this rule that I'm telling here, that product of HCF and LCM of two numbers. If I am given two numbers, if I find out their HCF and their LCM, if I multiply both HCF and LCM, I'll ultimately get the product of two numbers. So this is something that you can remember. Okay, HCF into LCM is always the product of two numbers. For example, if there are two numbers HX and HY, where H is HCF, so LCM will be HXY, right? Then H into HXY, which is HCF is H, LCM is HXY, is product of two numbers. Two numbers that we assumed are HX and HY. We have written them in this form, okay? For example, but never forget this, okay? This you should never forget. A lot of people know this rule already. HCF into LCM is product of the numbers, but this is only applicable for two numbers, okay? Not beyond that. We'll just verify it. Let me just verify. How will we do this? Just a second. So say I take two numbers, okay? I take two numbers, say 5 and say 25. This is only applicable for two numbers. I'm saying again and again. So HCF into LCM. What will be the HCF of 5 and 25? It will be 5, right? Calculate kar lena khud se. And what will be the LCM? It will be 25 only, right? So HCF, which is 5, into LCM, which is 25, is equal to product of two numbers. Do the product of two numbers given. They were 5 and 25 only. Similarly, if I take two numbers, say 3 and 4. Okay. So HCF of 3 and 4 will be 1. LCM of 3 and 4 will be 12. So I got HCF and LCM. This will always be equal to product of two numbers which are given, 3 into 4. Is it correct or not? LHS is equal to RHS, right? So this rule only applies to two numbers. For example, if I take one more case, if I take the case of three numbers, say I take 2, 3, and say 4. Okay. What will be the HCF of all of these three? It will be 1, right? HCF of 2, 3, 4 will be 1 into LCM. LCM of 2, 3, 4, it is how much? 12, right? If you calculate, is equal to product of the numbers, right? If you take out the product of numbers 2, 3, 4, it will be 6 into 4, 24. Is LHS equal to RHS? We get 12 equal to 24. Is LHS equal to RHS? No, right? That
No,
is why
sir.
this rule does not apply to more than two numbers. Okay, always remember this. People commit a lot of mistakes. So if you will get questions related to this rule, how will you get it? It'll the question the guy setting the question, he'll set a question like there are two numbers and their HCF is 1, LCM is 2. Find the product of two numbers. Or he'll say there are two numbers, one of them is 3, and the product of or the LCM of two numbers and HCF of these numbers is this and this. Find the other number. So put it in the equation and get the answer. Okay, that's how you'll be getting some question related to this. Is this clear? This rule was very important.
Yes.
And it's a simple rule. LCM we've already seen. HCF we've already seen. Let's talk about prime factorization. What is prime factorization? We already know this. हम यही कर रहे हैं तब से, ठीक है? We have been doing this since the beginning. Prime factorization. Prime factorization allows us to write any number as a product of prime factors. It is a way of expressing a number as a product of its primes. To do prime factorization, we need to break a number down to its prime factors. The prime factorization of 12 is. So I told you, right? When we find out the HCF, the LCM, we always write the prime factorization, not 1, because 1 was not prime. Great. So 12 will be written as product of its primes, 2 into 2 into 3. Make sure all the numbers in this multiplication that you are writing are prime. Warna fir wo, or it will not be called the prime factorization, right? I could have written this as 2 into 6, but this is not the prime factorization. Why? Because 6 is not prime here. So prime factorization of 12 is this. Is this understood? This is very useful while calculating HCF, LCM, and many other things. Okay. Clear?
Yes, sir.
Let's come to problem solving for today. Okay, so whatever we have learned so far, we'll be applying it. Okay, let's solve this now. So the question here is 3 by 4 is not a. You have to find out 3 by 4 is not a rational number or not a fraction or not a decimal or not an integer. I give all of you 2 minutes to answer this. Okay, 2 minutes nahi, 50 seconds. 2 seconds is too much for this. Okay.
Sir, D.
Okay, great. So very easy question. Okay, 3 by 4. We know it's a rational number. Why? Because it can be written in the form of p by q, where q is not equal to 0. So a will not be the answer. Fraction. It's a fraction because it has a numerator and a denominator. It's a fraction. Decimal, yes. If you solve 3 by 4, it will come out as 0.75. So we have this point involved here. So it's a decimal as well. But not an integer, because integer is a whole number and integers never have a fractional part. Okay. So it's not an integer. Okay. It's a rational number. It's a fraction. It's a decimal, but not an integer. So why did I include this question? To tell you that a number can be uh, uh, categorized into multiple categories. It could be a rational number at the same time, fraction at the same time, decimal at the same time. Okay, that's it. Now let's go ahead. This question we have now, 5 by 1 is not a. Answer this question.
Rational number A.
Yeah, yes. Even write in the chat box as well. Okay. जितने के जितने हो, जितने भी all of you who are present here, I want you to solve this. Okay. Find out the answer. Okay, all of you are getting A. Somebody is getting B as well. Fine, let's see who is correct, who is not. See, 5 by 1. When we check it as a rational number, what will I see? I'll check 5 by 1 and I'll check if it can be written in the form of P by Q. Yes, 5 by 1 and Q is not equal to 0. So yes, this is a rational number. Okay, this is a rational number. What is it asking? It is asking 5 by 1 is not a. So we are checking rational number. So we'll always check, can it be written in the form of rational number P by Q? Yes, it can be written and Q is not equal to 0. So it is a rational number. Fraction 5 by 1 can be simplified to 5, right? So इसका numerator तो है, there is no denominator. Real, every number is a real number except complex and imaginary. Okay, so it is not, it's a real number, right? Integer, yes, because 5 is an integer. तो ये क्या नहीं है? फ्रैक्शन नहीं है ये, ठीक है? इट्स नॉट अ फ्रैक्शन. गॉट इट? इट इज नॉट अ फ्रैक्शन.
Yes.
या, गॉट इट? So these are simple questions. I brought it to you because I knew there'll be students who will be having slight confusions. But I hope this is clear now, right? किसी को कोई doubt है तो you can let me know if you guys have any doubt.
No, sir.
Anyone else? Fine. So this was a very easy problem. Okay. Let's go to the next question. This question we have now. This is slightly difficult. Pi minus 22 by 7 will be a rational number or an irrational number. Solve this.
Sir, B.
Yes, yes. Keep solving, keep solving. जिसको जिसको आते आ रहा है, you can keep writing your answer. Okay. So you guys are writing. Okay. Let's see the answer. Okay. So it's irrational. Okay. Option B is correct. Now, why is option B correct? We were given pi minus 22 by 7. Okay. Now I'll tell you a very interesting thing. See this pi that we talk about, mostly it is used in areas, okay? When we talk about circular areas, okay, where we have curves, then only pi will be something that you'll encounter. But pi, देखिए, is a number, okay? What is this 22 by 7? Why do we use 22 by 7 in place of pi? In geometry, when you start geometry and you encounter pi, it will always be written that we use pi equal to 22 by 7 to ease the calculation. So actual value of pi is not 22 by 7, okay? It is slightly different, but it is very close to 22 by 7. Just the way we round off, right? If I ask you what is the closest number to 1.999999, you'll say 2. Why do we write 2 in place of 1.999? Because it is easier to calculate with human hands, right? So 22 by 7 is not the actual value of pi, okay? It is taken to ease the calculation part. Is this clear? Now, we know that pi is an irrational number. Why pi is an irrational number? Because pi की जो actual value होती है, the actual value of pi is this, written on your screen, 3.141, 592, 653, 59 something, and so on, so on, so on. So, why is it an irrational number? Because we can see when we write its decimal part, there is no repetition in this thing after the decimal. That's why it's an irrational number. Okay, pi is an irrational number. Always remember this. So I have read somewhere that pi is rational by 22 by 7 rational. Okay. Now 22 by 7, this is rational. Why 22 by 7 is rational? Because you have read wrong. Okay, who is this student? Just a second. Soumya. देखिए, Soumya, I think you are saying the opposite. You are saying the opposite because शायद आपको याद नहीं है थोड़ा सा. I think you need to check those facts again, the book again. 22 by 7 is rational. Why is it not rational? Tell me. 22 by 7 is clearly written in form of P by Q, right? It is clear. It can be clearly written in the form of P by Q, where Q is not equal to 0. So very obviously 22 by 7 is, ऐसे तो you will say 3 by 7 is also irrational. 22 by 7 is rational, okay? Because P by Q, it can be written in form of P by Q, where Q is not equal to 0. Okay, fine. So pi minus 22 by 7. Pi is also 3 point something something something. 22 by 7, if you calculate, is also 3.14 something. Okay. But since pi and 22 by 7 do not have the exact same values, there will be some difference, right? कोई difference आएगा, there will be some difference like this. If you calculate pi minus 22 by 7, you'll be getting this thing right over here. Now pi is irrational, while 22 by 7 is rational, which is again the similar number without symmetry. So what do we get as a difference? When we calculate pi minus 22 by 7, we again get some number where there is no repetition after the decimal. So it's an irrational number, okay? The answer that we finally get after calculating pi minus 22 by 7, it is this part, right? This part. And, okay, not this part, this one, okay, over here, the difference that I have written. If you can see this difference. So there is no repetition after the decimal in the value of pi minus 22 by 7. Hence, this is irrational. Okay. And very clearly, I've written pi is not equal to 3.14. Okay? That is just approximation. We consider that for our convenience, or you can say calculation purposes. Okay. Easier calculations. So 22 by 7 is clearly rational, while pi is irrational. Always remember this. And irrational minus rational or rational minus irrational will always give you irrational. Hence, B is the correct answer to this question. Is this clear or not? So there are so many things that we learned today, right? Many exceptions. जैसे वो HCF LCM वाले मैंने आपको बताया, only it is applicable only for two numbers. We talked about rational numbers. So I hope you got a lot more clarity, right?
Yes,
Is this
sir.
understood, all of you?
Yes, sir. Yes, sir.
So this can be the most difficult question somebody can ask you regarding rational or irrational number. Okay, maybe in the interviews as well. ऐसे ही question पूछे आते हैं interviews में. When from a 12th student, what can you ask? You can check how is he speaking, how are his communication skills, what he thinks about, why he wants to pursue IPM. Those are all personal questions. But when you talk about the academic questions during interview, these small questions can be asked from you. Okay, so you always have to think properly. If the interviewer is asking, is it a very straight question or it has some hidden facts? Okay. Now let's go ahead. What do we have further? This is a question that a lot of students must have solved already, and many of you might not have seen this. But this is a very good question. When you solve this question, you will feel very good. Do you guys want to give it a try? All of you have like 4 minutes. Okay. I give you 3 to 4 minutes to solve this question.
$54.
Okay. Yash is saying 53. Others, give it a try. Okay, Karan is saying 54. Aryan says 54. So it looks like कि हमने ये question जो whatever we are solving here, nothing was taught to us, right? But it has hidden concepts from today's class only, okay? And this could be the toughest question somebody can ask you, even though it is very easy, okay, if you think deeper. But it's a bahar se it looks very tough, okay? Yeah, how can we guess AB into CD if the product is 629? How can we guess B into DC? Right. So, do you want me to solve this? Fine. See, let's try to solve this, okay? So, this, when you look at a question, you always have to extract the maximum information you can, okay, out of the statements given. So what can we see here? If AB into CD, these are two-digit numbers, right? AB is a two-digit number, CD is a two-digit number. It is, these are getting multiplied and we are getting a product 629. Again, what are we getting? BA into DC, okay? BA into DC, the numbers we can see here are getting reversed, right? AB becomes BA, CD becomes DC, okay? And again, we are getting some product. The product is big than the earlier number 629. It is becoming 5183. Okay. So that's one case. We have been told to find out the value of AB plus CD given that AB, BA, CD all are two-digit positive integers. Very clearly. These are all positive numbers, AB, CD. Okay. And options we have 54, 55, 51, 53. When we look at the options, we have 55, which is odd number, 51 odd number, 53 odd number. Only one even option is there, 54. Okay. Now see, if you start guessing the values of ABCD, maybe you are taking AB as 23, CD as 33, like that. Okay, you must be solving. But that is a very laborious process. Okay, you will have to take a lot of hit and trials, and you might end up getting frustrated, and you'll eventually leave the question. Okay. But what else can we do? What else can we do here? We have two-digit numbers getting multiplied, and we are getting a product. And if I further look at this product, which is 629, it is an odd number. There is nothing else that I can say about this number. Similarly, the other product that I was getting, DA into DC, when the numbers are being reversed and multiplied, I'm getting 5183. Okay. So 5183 is another number that we have. And this is also odd, okay? This is also odd. Now, since this number 629 and this number 5183 is a product which is odd, and we are getting it when two numbers are being multiplied, which are AB and CD. So, can we say something about the numbers being multiplied, AB and CD? AB into CD. Since this product is odd, then we can say that the numbers being multiplied will also be odd, because odd into odd number gives us an odd number. Say I multiply 13 into 15. What do I get? 130 and 65, 195, right? Which is odd. So odd number into odd number is an odd number. While if you multiply just one even number with any number, say 12 into 15, what will you get? 180, which is even number, right? So we always get an odd product when we multiply two odd numbers. That means AB will be odd, CD will be odd. Okay. Is this clear? यहाँ तक सबको clear है? If you have any doubt, let me know. Any doubt so far? Any doubt so far? Fine. I hope this is understood, right? Similarly, when we talk about BA and DC here, these are getting multiplied and we are getting an odd product, 5183. So BA and DC. Hi. Can you hear me? So sorry, there was some network issue. Am I audible, everyone?
Yes, sir.
Okay. So we were solving this question. Okay. So yes, we knew that AB is odd, CD is odd, 629 is odd, right? Because when we multiply odd and odd, we get odd product. Similarly, BA will be odd, DC will be odd, and the product 5 and 83 is also odd. So what can I say about the properties of these numbers A, B, C, D? These are odd, BA, DC, these are odd. So if I analyze A, B, C, D, B, A, D, C closely, if these are odd numbers, I can clearly say that B will be odd. See, how do we determine that a number is odd or not, even or not? We check the unit digit, right? We check the unit digit of that number. For example, if I say 62, you will just check this unit digit 2 and say that this is even because unit digit is divisible by 2. Similarly, in odd numbers, if I want to determine 63 is odd or not, I always check the unit digit, right? उसके पहले का तो we never check कि क्या है ना? So if unit digit is even, the number is even. If the unit digit is odd, the number is odd. And here AB was odd, so B will be odd. CD was also odd, so D will be odd. BA तो odd number है ही है because BA into DC was being multiplied. So A will also be odd and C will also be odd. Hence we get a very superb result, which is A is odd, C is odd, D is odd, B is odd. Is this clear? Is it clear to you?
Yes, sir.
Okay. Now what are we trying to find out at the end? AB plus CD, the sum of two odd numbers, because A, B, C, D are odd. So what will be the sum of two odd numbers? It will be even. Let us check in the options. Do we have an even number? We have 54. So 54 will be the correct answer to this question. Okay. Got it? Is it clear to
Yes.
you? See, now there'll be some students who will ask me, sir, then what are the exact values of these A, B, B, C जो भी number आप कह रहे हो? What are the exact values? A, B, C, D की अगर value निकालने आ जाए, देखिए आ सकता है. They can ask you find out the value of A plus B plus C plus D. In that case, you'll have to find out the value of A, B, C, D individually, right? So for that, to find out the value of A, B, C, D, you'll have to solve a lot. There'll be a lot of equations which will be over here. Lot of equations will be building up, okay? And to solve them manually is very difficult. But if you want to know the result, 37 and 17 are those two numbers, okay? Can you see clearly now? A, B both are odd, C, D both are odd. And if you add both these, you'll be getting 54, which is option A here. And if you multiply them, you'll be getting the same products, okay? Multiply 37 and 17, you'll get 629. Multiply 73 and 71, you will get 583. Is it clear now?
Yes,
Everyone,
sir.
write a yes in the chat box. Please write a yes in the chat box if you have clearly understood this.
Sir, can you tell how you added the numbers?
How will you
Added the numbers like A, B,
edit
and
the
C,
number?
D.
See, Abhigyan,
Yeah.
I knew AB is odd, CD is odd. If you add two odd numbers, say any two odd numbers, take 13 and 15. What do you get? You get 28. 28 is even. Similarly, if you take
28.
any other two numbers, say any other two numbers which are odd, say add 17 and 13. When I add two odd numbers, 17, 13, what do I get? I get 30. What is 30? 30 is an even number. Similarly, if I add, say, two another odd numbers, 11 and 9, 11 odd, 9 odd, but when I add them, I get 20. 20 is even. What do I see here? When I add two odd numbers, I get an even number. This is the result I can say, right? Add any two. देखिए मैं आपको बताता हूँ कैसे. Let's take a general case, okay? Let's take a general case. This is clear to you. Abhigyan, इतना आपको समझ में आया, right? कि A, B, C, D all are odd numbers. This is clear to you, right?
Yes, sir.
Yeah. Now what I'm doing is I am adding two odd numbers. So an odd number can be written as 2x plus 1, right? Because 2x तो उसका even part हो गया. As soon as you add 1 to it, it becomes odd. So an odd number can be written like this, right? Is this clear or not? It can be written in form of 2x plus 1. Another odd
Yes.
number can be written in the form of, say, 2y plus 1, right? Can be written, है ना? If I add two odd numbers, what will I get? I will get 2x plus 2y. So 2x plus 2y मिलेगा तो 2, I can write it as 2 times x plus y, right? And this 1 and 1 will add up, become 2. And again, if I take 2 common in everything, I'll get 2 times x plus y plus 1. So what is this in the end that we get? It is a multiple of 2 because 2 is being multiplied to x plus y plus 1. Now you put any value for x, y, you'll always get an even number because 2 is being multiplied. So when we add two odd numbers, as I showed you here, 2x plus 1, 2y plus 1, I always get an even number. And here in my question, A, B, C, D, I know are odd numbers. When I add them, I should get an even number. That is why I checked the options कि कहाँ पे even number का sum दे रखा है. 55, 51, 53 all were odd except 54. 54 was the only even number. And that's why I eliminated options B, D, C and chose option A as my correct answer. Is it clear now?
Sir, like they can ask also now what can be the number.
They can ask, okay, but then in that case you'll have a lot of solving, okay? आपको फिर यहाँ पे ना you'll have to write this AB as 10A plus B, CD as 10C plus D, here 10B plus A, 10C plus D, and then solve a lot, okay? So if you go deeper into solving and finding out the value of A, B, C, D, it'll be a long process, okay? We can also solve it, but it'll take a lot of time. That is why the questions are very cleverly set. Okay, ऐसे questions set करे जाते हैं very cleverly, so that you only pick up the clues needed to answer the question. Otherwise, he could have also given few more numbers in the option, right? वो option में 56, 66, 86, the question setter would have put more even numbers in the option, but he did not, because he only wants you to pick up those clues which are necessary to answer the question. Okay, otherwise so we can have multiple, we can find out multiple possibilities here, है ना? Is this understood? He only wants you to pick up those clues which are necessary to solve the question. Understood?
Okay, sir.
क्योंकि हमसे तो AB, we have not been asked the value of A, B, C, D individually. I was asked AB plus CD. Give me AB plus CD. I gave him the value AB plus CD. Am I in any form concerned about the values of A, B, C, D differently? No, right? I'm only concerned about AB plus CD. Question was only concerned about AB and CD. I gave the answer AB and CD, which was option A. I found out the answer, right? So when you solve a puzzle, you only have to focus on the required information. Okay. Otherwise, if you can find 1,000 multiple answers in between. What is the value of A, B, C, D, different things, but in exams you only have to solve what is required. Understood everyone?
Yes.
Is it clear? Fine, that's all about it. This was a very good question. Okay, now there are few doubts. How do you know the exact values of these numbers? See, because I have created this question, that's why I know the exact values of these numbers. Okay, so Meg, you can also calculate a question like this. For example, you can take any two odd numbers. Say take 13 and 15. Okay, take 13 and 15. AB will be 13, so A will be 1, B will be 3, CD will be 15, C will be 1, D will be 5. कोई जो भी product आएगा 13 and 15 का, say it is 185 or whatever it is, 295, 195 the product, उसको यहाँ लिख दीजिए, उन्हीं को उल्टा कर दीजिए, reverse it, 31 into 51, you will get some product, write it here, then find out the value of AB plus CD and write AB, BC, CD, D are all positive numbers. So you can create a question on your own, okay, and then set an option in the set an option which has a sum equal to the sum of 13 and 15 and बाकियों को और रख दीजिए. ऐसे मैंने एक क्वेश्चन बनाया, ठीक है. What if there is another even number in the options? If there is another even number in the options, then I'll have to individually find out the value of A, B, C, D. Okay, then this question is going to take a lot of time. It is better that we leave this question. फिर आपको, क्योंकि ऐश्वर्या, you will have to individually find out the value of all the digits, which is going to take a lot of time. You can see, right? आपको फिर कैसे निकालना पड़ेगा, 10A plus B, 10C plus D उस फॉर्म में लिखना पड़ेगा, then equations बनेंगी, प्लस माइनस करना पड़ेगा equations को, and then maybe in the 10th 11th step we'll find the answer. इससे अच्छा तो ये है कि I skip this question and go to some other question, right, in the examination. Got it? Then there are more doubts. Stuti sir, how will know find the number is, how will we know that we have to find whether number is odd or even? So Stuti, हमने अभी अभी देखा कि product is odd, and when do we have an odd product? When two numbers multiplying are odd. तो जो numbers हमारे multiply हो रहे हैं वो odd होंगे. That is why we are getting an odd product. That's why I called A, B, C, D and B, A, D, C odds. Okay. अब clear है आपको, Mehak and everyone? Is it clear to you now?
Yes, sir.
Great. ऐसे करके क्वेश्चन होते हैं, ठीक है. अब चलते हैं आगे. That's it. So fine. That's it for today. Okay, I'll give you a few more questions. Give me 2 minutes. Okay, I'll give you 2-3 more questions, good questions to solve. Be online for 2 minutes. Okay, give me 2 minutes. Okay, so sorry. Can you see my screen?
Yes, sir.
Okay. So we have this question over here. Okay, very easy question. Yeah, usually we encounter such questions in class 6. Okay. So what is the difference in the place values of 2 in this numeral? We have this number and we have to find out the difference in the place values. Do you know how to calculate the place values? So see, there might be few students who have not answered even a single question today, but there is no need to be afraid. Okay, no need to be scared. We are learning. Okay, once we complete numbers, then we'll look back and see whether all can solve or not. Okay, fine. So see, whenever we are talking about place values, what will we see? We'll read all the numbers. Okay, we'll read all the digits in the number. So in this number 724823, 3 is the ones digit, 2 is the tens digit, A is the hundreds digit, 4 is the thousands digit, 2 is the 10,000 digit, and this is lakhs digit, right? Now if I talk about the place value, the place of 2 is tens. So I'll take the number 2 and multiply with it with its place. Okay. The place it is at. So it is at tens place because we read the number like ones, tens, hundreds, thousand, 10,000, lakh, 10 lakh, crore, 10 crore, like this. Okay. So 2 into 10 because 2 is at the tens place. So place value of 2 is 20 in this case. But there is one more 2 hidden over here. It is at the ones, tens, hundred thousand, 10,000 place. So 2 will be written and its place. It is at the 10,000 place, which is nothing but 20,000, right? Now the question is asking me find out the difference in the place value. So difference between 20 and 20,000 is nothing but 19980. This is the correct answer. Is it clear or not?
Yes, sir.
Fine. Great. So काफी लोग तो solve कर भी पा रहे हैं. Lot of you are able to solve. Just a second. Now we have just a second. Okay. Just a second. So far, whatever we studied is clear, right? अगर किसी को कोई doubt है, if you guys have any doubt, till then you can ask your doubts, okay? I'm just finding a couple of questions for you. Give me 2 minutes, okay? If you guys have any doubt, okay, not even if it is not from the class, any doubt regarding numbers, you can ask it. Give me 2-3 more minutes, okay? I'm just getting some questions. Okay. Fine. Can you all see my screen?
Yes, sir.
Can you all? Yeah. So I have a question here. See, it is slightly. I have not told the concept in the class, but you can give it a try. Okay, this question. This would be the last question for the day, and this is a very good question. Okay, it was asked in one of the CAT exams. Okay. So CAT, if you know, is just like your IPMAT exam, but it is after graduation. Okay. So this is a question. CUT students, I think they are done for the day. Okay. CUT students can leave if they want to. IPMAT students can stay, or CUT students, if you want to say this question, this is the last question. You can stay back. Okay. This is a question which has a very good concept involved, and if you remember that concept, you will be solving many questions. Okay. So I am bringing those concepts to you, which will help you to solve a lot of questions. Okay. So how will we solve this question? Okay, so I'll just tell you a concept first. See, we already know what are prime numbers, right? So all the prime numbers, I'm telling you a rule, okay? All the prime numbers greater than 3 can be written in this form, okay? 6k plus minus 1. What does it mean? Tell me any prime number greater than 3. 5. Can it be written in the form of 6k plus or minus 1? When I've written 6k plus minus 1, I'm talking about two forms, okay? 6k plus 1 form bhi ho sakta hai. It can be in this form or it can be in this form as well, okay? So 5, if you see, can be written as 6 into 1 minus 1, right? So yes, we can say that any prime number greater than 3 can be written in the form of 6k plus minus 1. Okay. Or if you take 7, 7 can be written as 6 into 1 plus 1. Yes, 7 is a prime number and it can be written in the form of 6k plus 1. Very clear. Let us talk about any other prime number, say 23. It can be written as 6 into 4 minus 1. So This is correct, right? Any prime number which is greater than 3 can be written in the form of 6k plus minus 1. Now, our question, is this clear to you? This concept that I told you, that any prime number greater
Yes.
than 3 can be written in the form of 6k plus minus 1. Okay, if any of you has a doubt, you can ask me here, okay, because it is very helpful in solving this question. So here, I have been asked if p is any prime number greater than 43, then what is the remainder when p square is divided by 24? So I know that prime can be written either as 6k plus minus 1. Okay, it can be written as 6k plus 1 as well. It can be written as 6k minus 1 as well, right? And we have to divide a prime number greater than 43. It is given as p. We have to divide p square by 24, and we have to check what will be the remainder. Okay, so see here, we are very familiar with this rule now, that any prime greater than 3 can be written in the form of 6k plus 1. And p square minus 1 will be divisible by 24. Okay, um, if you take any prime greater than 24, say you take 53 is a prime, right? 53 is a prime, isn't it? Isn't it?
Yes.
Can you all hear me clearly? I think there's some issue with the network. Can you all hear me clearly? Please write yes in the chat box.
Yes. Yes.
Okay. Okay. So I told you that any prime greater than 3 can be written as 6k plus minus 1. And here in the question we have been asked, there's any prime number greater than 43, then what is the remainder when p square is divided by 24? So I have taken the prime as 6k plus minus 1, okay, and I have squared it. So when you do a plus minus b square, this is what you get, right? A square plus b square plus minus ab, right? I have written both the cases in the same, okay? ये clear है ना? मैंने कैसे लिखा? How have I done this square? You know the formula of a plus b square, right?
Yes, sir.
Yeah. So now if you put k equal to 1 or k equal to 2 or k equal to 3, okay, anything in this, you will always get a number, you will always get the remainder as 1, okay? You will always get the, say put k equal to 1, you will get 36 plus 12 plus 1, okay? What do we get? We get 49. So I had a prime 6k plus minus 1. I squared it. I got this. And when it is divided, actually this, when you put k equal to 1, you will only be getting a prime like 7. Okay. So if you put some bigger value of k, what will you get? Say you uh, put 8 here. Okay. Put 8 here. You will be getting 48, minus 1, 47. So right, 47 into 47. Okay, there are negative reminders here. Okay, so we'll do one thing. We'll see this problem in the next session. Okay, because there's something related to negative reminders over here. Okay, so in next class, what will we study? We'll study how to calculate the total number of factors. We'll see how to calculate the total number of odd factors of a number or total number of even factors of a number, how to find out sum of all the factors of a number, how to find out product of all the factors of a number, and we'll see basics of remainders. Okay. We'll see this in the next session. Okay. Because there's something related to negative remainders over here. Okay. Today's session understood to everyone? Whatever we did today
Yes,
is
sir.
that clear?
Very well.
All these questions are clear, right? All these concepts are clear, right?
Yes.
If you guys have any doubt, let me know, and please write a feedback like the session was good, best, okay, nice, whatever you want to write. So that if there's any scope of improvement, I'll do that. Okay. So there were some non-enrolled students as well, right? If you guys want to enroll, you can visit iQuanta.in our website and enroll for the course. This was a very basic class. In the next class, I am telling you already, we'll be seeing how to calculate total number of factors, sum of all the factors, product of all the factors. Okay. ठीक है. And उसमें हम थोड़ा सा रिमाइंडर्स का बेसिक भी देखेंगे. ठीक है. Fine. Thank you, Soumya. Thank you, Dushyant. Thank you, Mahek. Now you should not never be confused about these. What I'll do is I'll drop some assignment questions for you in the group, okay? Because जो आपका website पे the assignment you have the dashboard, it has concepts, a few more concepts involved. So you guys might be feeling that we have not studied this in the class and they have given us assignment which has questions from another concept. So that's why I'm not giving you the assignments today. Do one thing, okay? All of you text me personally with your number on which you want the access and the email ID on which you want the access. I'll give you the access of the website, okay, where you have the these assignments. For logical reasoning, your assignments are ready. I'll give it to you. For VRC class, that was yesterday, English class, reading comprehension assignments are ready already, okay? And that's it. That's it, okay? Quant assignment, I'll give you a set of 20 questions today by evening. Okay, you can solve those. And if you have any doubts, we'll solve them in the next week. Also, I'll show you one more thing. Just a second. In group you will give. Yes, in this WhatsApp group only. Just for today, okay? Next week, आपको सारा सब कुछ will be available in the website only. So see, you guys have been added to a Facebook group, right?
Yes.
So ये आपका ग्रुप है, I guess 2024 CUT and IPMAT Quants, right? Can you see my screen?
Yes, sir.
Okay. So when you open this group on Facebook, you will see this box, okay? Write something box over here. In this box, what you have to do is you have to put your doubts, okay? For example, I have a doubt in today's class and I could not understand a question. So you will just take a screenshot and post it here. How do you have to post it? I'll tell you. On this particular box, just write either the question, what is the remainder, whatever it is, okay? You can just copy paste your text, or otherwise what you can do is you can also attach a picture with your particular question. That so for suppose you have written something in your notebook and you want to ask it as a doubt, take a picture of that particular question and attach your picture, okay? You can post this from mobile as well, okay? That is one thing. And apart from that, this is how you have to post it out, okay? So for example, I'm just posting something. I have a doubt, okay? just write your text here. Okay? Write your text and just post it. Now, what will happen after you post? After you have posted, our doubt solvers or the faculties will be checking your particular doubt, your question, and they will comment here. Answer is this. And they will give you a detailed explanation, okay, of your answer. They will just write something, and post it, okay? And you will get your answer like this. Suppose you still have some doubts with the answer, what will you do? You will always click on reply. Once you reply to my comment, I'll get to know that, okay, this particular student, I gave him a solution, but he could not understand. So you can write, sir, I could not understand line 3, right? Please explain again. That's how you have to ask doubts. Okay?
Yes.
That's it. So your doubts
Yes, sir.
are there. We'll give you the assignments, okay? I told you to send me the email and mobile number on which you want the access to the dashboard and send it to me personally, okay? I think somewhere in one of the weekdays, coming weekdays, I'll take a class where I'll tell you how to access the dashboard, okay? How to access the assignment, how to write the assignment so that everything is clear. We'll meet next week now, Saturday. Most probably, we'll put your quants class on Saturday now, okay? And that's it for the day. Okay. I hope you had a good session. Thank you so much for coming. And if you have any doubts, you can keep posting. Okay.
Thank
Thank
you,
you so
sir.
much. Thank you. Thank you. Bye bye, everyone.
Yes. Bye.
Bye bye bye.